What's up, guys? My name is Michael and welcome to my YouTube channel. Today we are going to go over this problem called 2D array, DS. Okay, so basically we have this thing. We have like a 6x6 array, and then we have an hourglass, which is a subset of values with indices falling in this pattern, R, geographic representation. So it has this pattern of certain number of numbers, right? Like A, B, C, then D, but we skip like a space here and skip a space here. Then we have E, F, and G. So there are currently 16 hourglasses in R. An hourglass sum is the sum of an hourglass's values. Calculate the hourglass sum for every hourglass in R, and then print out the maximum hourglass sum. The array would always be 6x6. So basically, what we're doing here is we're just going to sum up every hourglass. So as you can see here, -9 plus -9 plus -9 plus -9 plus -9, and then plus -9 plus -9 plus -9. So this would be -9 times 1, 2, 3, 4, 5, 6, 7, right? If you add up all these values, this hourglass, -9 plus -9 plus -9 plus this -9 plus -9 plus -9 plus -9, you get -9 times 7, which is going to be -63. So that's what the first value here is for, right? That's what this first value is, right? And then we have the next hourglass, which is going to be -9, -9. -9 plus -9 plus 1, then we're going to plus 0, then we're going to plus -9 plus -9 plus 1. And as you can see here, if you were to sum them up, you have -34. So that's what you have here. So we're just going to continue doing this pattern over and over again until we get to the end. And then what they want us to do is they want us to get the maximum hourglass sum found in an array. So to do this, it's actually not that difficult. So what I'm going to do is that in order to make it easier for me, I'm going to create two functions. One is going to be called inbounds, which is just checking if it's actually in bounds of my current index is in bounds. And the second one is going to check if is just going to go through all the surrounding locations of all my values that I'm going to add up. So first I'm going to create one for the inbounds. So let's say I had a Boolean. It's going to be a Boolean because it's going to be true or false. And then it's going to be inbounds. And what I'm going to take is I'm going to take the 2D vector. And then I'm going to take the current index, which is going to be I and J. I'm just going to check if I is greater than or equal to 0 and I is less than r dot size, right? So that's like the first value that we're checking is just making sure that's in between the sizes, right? So I is going to represent our current row, right? Our current row. So that's why we're just checking the number of columns in our thing, and that's going to be r dot size. And I also have to check if j is the same thing. So j is greater than or equal to 0, and j is less than r at 0 dot size. So this is going to represent like this is going to represent the number of columns, making sure that my current column index, so I have I and then j, making sure this is between the current sizes, right? The current size. So that this is just making sure that like our current indexes are inside our array, right? They're just in bounds. Okay. Now what I'm gonna do is holy shit. I'm gonna put a timer. That scared the hell out of me. Okay. Now what I'm gonna do is I'm going to create an array that's gonna go through all the adjacent indices, right? Besides the two that are left out. So if we look at an hourglass, it's basically this figure where it's have A, B, C, D, E, F, G, right? And then we're leaving out the left side and the right side. Okay, so what I'm going to do is I'm actually going to create all the values of the surrounding location that we have to check and have to sum up. So here we have if our current location here of D is at IJ, right? Let's say our current location here is in this position. So what would be the the locations, surrounding locations? Well, simple. The one on the diagonal is just going to be, so if, let's say our current location is at like 1, 1, right? D is like 1, 1. Then diagonal is going to be 0, 0, right? So it's just going to be one less than the column index, and one less than the row index. So A will be at 0, 0. And then B would be at 0, 1. So if D is 1, 1, it's going to be at 0, 1. So it's going to be one less, one less than in the row column. Okay, in the row column. And then C would be the diagonal. And so let's say D was 1, 1. C would be whatever's on this diagonal, which is going to be one less than in the row column, but it's going to be one more in the corresponding actual column. So I know this is kind of hard to write, but I'll just I don't have my pen with me, so I'll try to bear with my terrible handwriting. So let's say we have this. Bear with my terrible handwriting. Okay. This is really hard. I'm using a mouse pad. Okay, so let's say our current location is here, right? So it's at 0, 0, 1, then 2, then this is 0, then 1, and 2. So if we were to actually check the current location, this is going to be 1, 0, 0, right? This is going to be 0, 1. This is going to be, 0, 2. This is going to be 0, 2. Right, so here's 0, 2. Here would be, let's see, it would be 2, 0. Here would be 2, 1, and here would be 2, 2. So if we were to say our current index is at ij, where our I is our current row, and j is our current column, then we could actually have an offset and just check these surrounding locations. So this one, this one, this one, this one, this one, and this one, right? We just have an offset. So this one, so if our current index is at I and then j, right? So let's say x is at ij, our center is at ij. So all we have to do is just, for the one above us, we just have to subtract 1 from the row, and the one below us, we just have to add 1 to our row, right? So both of this part and this part, we just add 1, and this one we just subtract 1, right? And then the diagonal ones, we just have to subtract 1 for both of them, and then here we would just add 1 and subtract 1 for the row column. Here we're just going to add 1 and add 1 to the row column, and here we're just going to add 1 to the row column and subtract 1 for the column, on the column. So yeah, that's basically what we're going to do. So if we're going to pair up the offsets, it'll be something like, let's see. Here we're going to subtract 1 from the row column, so -1 and -1, so it'll be -1, -1, right? Yeah. And then here would be -1, hold up. So -1, -1, right? And then here it's going to be 0, 1, which is going to be -1, 0, right? -1, 0. I'm just naming all the offsets. Here it would be, what is this? It would be -1 on the row, and then +1 for the column. So it would be -1, +1, right? And then here it would be -1, no, it would be +1 on the row column, but then -1 on the column. So +1 on the row column, -1 on the column. Here it would just be +1 on the row and then nothing for the column, so +1 on the row. nothing for column, so it would be 0. And then here it would be +1 because it's going to be diagonal. Okay, so it would be +1 +1. So these are just going to be the offsets for all the locations. So I have 1, 2, 3, 4, 5, 6, and as you see, 1, 2, 3, 4, 5, 6, and then I need to include the center also, which is my current index, which is going to be 0, 0. Okay. Okay, so then all we have to do is put these offsets in our array. No, not array, and yeah, put it in an array or a pair, whatever you want it to be. I might actually just use a pair. And then we just have to loop through all our values in our big array and then just sum up the current locations that are in this offset. And each time we go through an offset of our surrounding locations, we're just going to check if it's in bounds. So if one of them is not in bounds, then we can't sum them up, so we just break. So that's why we have the inbounds function. So yeah, I'm going to go over that now and show you guys how to do it. So if you were to code this up now, it doesn't take that long. Okay, so we have the inbounds. Now what we need to do is here we're going to go loop through the rows and the columns. Okay, so now what we're going to do is we're going to get the vector of pairs. It's going to be like, this is going to be like the offset. So let's go back to our thing. We have -1, -1. 0, 0. Actually, we should call it neighbors. 0, 0, -1, 0. 1, 1, -1, 1, 1, 1, oh crap. 1, 1, 1, -1, 1, 0. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. Is it 8? I don't think so. It's 1, 2, 3, 4, 5, 6, 7. It should be 7. Am I 1, 2, 3, 4, 5, 6, 7? It should be 7. 1, 2, 3, 4, 5, 6, 7. Where we have an extra. Oh, we have an extra 1, 1. Yeah. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We need a 0, 0. Oh. Okay, well now we're missing something. 1, 2, 3, 4, 5, 6, 7. Oh, we have 7. Okay. Alright, so now we're going to go through all our offsets of where we're adding to our, and then we're going to check if it's in bounds. So now we're going to loop through for every, let's call it neighbor. So we're just going to add it to our current index, so I plus neighbor dot first. J plus neighbor dot second. Yeah, okay, and this is just gonna be like, I don't know. This is our current value. Oh, we gotta check if it's in bounds. Dang, I forgot. Let's just call it like index. Let's see, current row index. Current row index. Yeah, let's do that. In ij plus j at first, and then current column is going to equal to I plus neighbor dot second. Okay, so now once we have this, all we have to do is we have to go through our arrays. So if r at current row, current column, our current row, current column, we need to check if this is in bounds. So I forgot. Let's check if current row, current column is in bounds. So if it's not in bounds, we just break, right? So let's see. If current is in bounds, then we just sum it up. So we just have to do R, and then we have current row and current column. Okay, so if it's in bounds, we're just going to okay, so if it's in bounds, we're just going to like let's see, if it's in bounds, we're just going to sum it up. Okay, so let's see, sum. We have a sum variable. So if it's in bounds, sum plus plus. Otherwise, we have to reach break, because that means that you can't do it. You can't sum it up. So yeah, so once we're done summing, we just need like an actual, what do they want? If they want the smallest sum, let's see. Oh, maximum. So they want the maximum hourglass sum. Okay. So let's go through here. Okay. So now we have max sum. So now we just need to do this. Crap cakes. Okay. We're gonna go through here, and then we're just going to do like sum max sum is equal to max sum max sum. Okay. And once we have here, we're just gonna return max sum. Okay. Should work. Okay. What? It's not. Something's failing. Okay. Why is it failing? Wrong answer. Expected output 19. Wait. What is my expected output? Seven. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. I should go through all of them. So let's see. Let's see why it's not working. Oh, maybe it's our inbounds. This might be swapped. So let's check if the number of rows is. This should be J. Yeah. Okay, it's still failing. Okay. What is it printing out though? Biggest question is, what is it printing out? Oh, we did sum plus equals. We have to do sum plus equals the current row, current column. Yeah, we didn't actually add the sum. We just incremented. Now it should work. Okay. Well, it's working for all the cases, most of the cases. We're in the first star. I don't know what that means. Failing 2 test cases. Maybe this has to do with like 00012. What is the problem? Let's see. Let's think. I'm looking through here. Looking through here. All right. What is the test case that's failing? Oh, wait. No, 0 works though. 0 should work. Zero definitely should work. Oh, this should be integer underscore min. So we get the maximum. So it's not 0. Oh, we're still failing something. Okay, we're still failing. Expected output is -6. What is our output? Let's see. Their output is 0. That's super strange. That is so strange. Sum maximum sum is integer underscore min, and then we're gonna get the maximum sum max. Max sum. Offset is -1, -1, -1. Why is it 0? Okay, let's actually print out all the sums that we have. See what that does. Okay. And we should be able to get like most of them. 0, 0, 0, 0, -6, -20. What's the answer? Maximum number? Oh, I understand why. Because if it's not, okay, what's happening is that sometimes this breaks out and then this sum still gets put in here. So we actually want this to only work when we're, oh my gosh, okay, yeah, I understand why. We basically want it to only work, we only want to get the maximum when we didn't break into here. So what's happening is that sometimes this never runs, and then this sum, which is 0, is getting put into this max. Like we're replacing the maximum sum with 0, which is not how you want it to work. So yeah, so we should use an if statement. If sum is not equal to 0. Actually, we should just have a boolean. So like say boolean added sum. So here we're going to set it to false. If it's inside here, we're just going to set it to true. Actually, that's not a good idea because what if it breaks in the middle? That's a problem. Okay, yeah. So added sum is equal to false. If it's inbound, we're going to sum added sum is going to set to true. Otherwise, added sum false, so that means don't check it. So let's actually say check sum. So if we check sum is true, then we're just gonna put this max sum. Okay. And the reason why this works, the reason why we have to do this is because sometimes this never gets called, and 0 is getting replaced with negative numbers, right? It's checking, like, it's summing up 0. It's using 0 as, like, our starting value as the thing when that's not what we want it to work. Okay, then now it should work. Yep, now it works. Okay, so that's basically how you guys do this problem. Hope you guys enjoyed this video. Rate, comment, subscribe. This is a 2D array DS. Yeah, I'll see you guys later. Peace.